Okay, so let's start our session. People who are willing to join will join. So first of all, a very good evening, everyone. This is Nikhil Nandam, and this is your last session for Python training organized by the Coding Club of JNTUHCEH. So let's continue from where we left off in the last session. So this is session 6, and we started object-oriented programming in Python, right? So the next topic is methods. And what are methods? Methods are functions defined inside the body of a class. They are used to define the behaviors of an object. Like we have discussed previously that each object consists of an attributes and its behavior. So the behavior of the objects is determined by those methods that we define inside the class. Okay, so there are three different types of methods, and the first one being instance methods. Instance methods are those methods where every object or instance of the class will have a copy of the method within the object. So each object will have a copy of the method, okay? And each instance will have its own copy of the method that is bound to the instance. Sorry, this is method. Okay. So these methods will not be shared among the instances. They will be unique to the object that it is bound with. So let's see an example. Here we have defined a class named parrot, and the constructor contains two attributes, namely name and age. And there are two instance methods that you can see over here, that is which is sing and dance. And we have created an object named blue, object of the parrot class named blue, with the name blue and its age being 10. So let's run this cell, and the same thing what I've just told is in the description. And so each of these methods, each of the objects contains a unique copy of these methods. So when you run blue.sing, blue sings happy, and blue.dance. Now blue is dancing. So if you create another object with this for this class, that object will also have a copy of these methods bound to them. So the next type of methods are class methods. A class method is a method that is bound to a class rather than its object. We have seen just now, right? Instance methods are those bound to objects, but class methods are bound to the class they're defined to. Class methods, unlike instance methods, are shared among all the objects of the class. So there is no unique copy to each object of the class. There is just one copy that is sitting in the class, and all the objects of that class share that method. Okay. Each object doesn't have their own copy of the class method. Only one copy of the class method will be used by all instances of the class. The class method can be called by both the class as well as its object. The class method is always attached to a class with the first argument as the class itself, that is CLS. You have to keep the parameter argument as CLS itself. And we generally use class method to create factory methods. And what are factory methods? Factory methods return class objects. Factory methods are similar to constructors, but they are used for different use cases. We'll see an example below. The syntax for the class method is as follows. You have to use the decorator add class method. Note this carefully. You have to use @class method before the definition of the class. Sorry, method. Like this, as shown in this cell. So now let's see an example. Here we have defined a class named person, and this is the constructor with the name and age. Here we have defined a class method from birth year. So when we want to create an instance for the person class with not age but his birth year, so we can use this factory method. And you can see the decorator over here, @class method being mentioned for the method from birth year. And also note the first parameter being CLS. Okay. And so you can use both the constructor as well as the class method that is from birth year to create an instance of the person class. Let's run this cell. And you have created a person of the instance of the person class named person, and his name is Adam and his age is 19. So when you use dot display method, you get his age being printed out. Adam's age is 19. And so this here we are using the a class method to create a instance of the person class from the using the birth year method. And his we are creating an object named person1, and his name is John, and he's born in 1985. So let's run this cell, and so his age is calculated as 37. Yes, he's 37. This is 2022, right? He's 37. So moving on to the third type of methods, that is static method. A static method is also a method that is bound to the class and not the object of the class. This is similar to the class method. A static method cannot access or modify the class state. It is simply present in the class because it makes sense for the method to be present in the class. Uh, we'll see an example that probably gives you a better understanding or better idea of what a static method is. But for now, let us discuss a few more points about it. And as we have seen, the class method decorator is used to create a class method, and similarly, the @static method decorator is used to create a static method. Now, let's discuss when to use class method and the differences between class method versus static method. So, a class method takes CLS as the first parameter, while a static method needs no specific parameters. It is not mandatory that you have to use class method for the static method. Class parameter, sorry. A class method can access or modify the class state, while a static method can't access or modify it. In general, static methods know nothing about the class state. They are utility type methods that take some parameters and work upon those parameters. On the other hand, class methods must have a class as a parameter. That is CLS. We have seen in the first point, right? And we also use @class method decorator in Python to create a class method. And we use @static method decorator to create a static method in Python. And when to use what? We generally use class method to create factory methods. Factory methods return class objects similar to constructor for different use cases. We've seen that above. We generally use static methods to create utility functions. Now, let's see an example that probably illustrates the use of static method and class method in a more clear way. Here we have used the same person class as above, just that we have added a static method to check if a person is an adult or not. As you can see over here, this isAdult is a static method used that is decorated using the @static method decorator. And the functionality of this method is to return true if the person's age is above 18 and return false if it is not. So this is one example where we have created two instances of the person class. One is named as person1 and the other is named as person2. So the age of person1, that is Mayank, is 21. And we have used the from birth year class method to create another instance of the class. And if he's born in 1996, his age will be 26 right now. So, and we've also used the static method isAdult to check if a person whose age is 22 is an adult or not. Note that the isAdult method is not bound to any of the attributes or the class variables that it is contained in, but we are putting it simply in the person class because it is related to the person. And as we have discussed previously, it cannot modify the state of a class since it is not bound to any of the attributes, class attributes or methods. So that is the difference between a static method and a class method. So now let's move on to the next topic, which is inheritance. So inheritance, what is inheritance? Inheritance is a powerful feature in object-oriented programming. It refers to defining a class with little or no modification to an existing class. And the new class is called derived or child class, and the one from which it inherits is called the base or parent class. So the syntax for inheritance. The syntax is as follows. You have a class named base class, or any name for that matter, and this that contains the body of the base class, and then the derived class. And then when you in the definition of the derived class, you have to mention the name of the base class in parentheses as shown: class, derived class, open parenthesis, base class, close parenthesis, and then a colon, and then the body of the derived class. Note the parenthesis base class in the derived class definition. Derived class inherits features from the base class where new features can be added to it. This results in reusability of code so that you do not have to type the same code again and again and make it duplicate. It makes it more concise and short. So let's see an example of inheritance. Here we have defined a class named Polygon. Polygon, as you might know, is a closed figure with 3 or more sides. So this is the constructor for the Polygon class, and we have an attribute named n that denotes the number of sides, and a list named sides that stores the length of each side in a list, and then a function input sides to input the length of each side from the user, and a function display sides that is used to display the length of each side. So let's run this cell, and here we have created another class called triangle. And since a triangle is a polygon, we can use the concept of inheritance to extend our functionality of the triangle class. Here, as you can see, we have mentioned the polygon class inside the parenthesis beside the name of the triangle class. So we are inheriting all the properties of the polygon class into our triangle class. And this is our constructor. We are calling the constructor of the polygon class from the base derived class using the polygon dot underscore underscore init and passing 3 as the number of sides parameter. And here we have defined a function called find area, and the area of a triangle is calculated using this formula. Area is equal to s under root s into s minus a into s minus b into s minus c. So we are using that formula to calculate the area of the triangle in this find area method. And here we are inputting the sides of the triangle from the user. Let us say 3 is 1, 4 is 1, and 5 is 1. As you can see, side 1 is 3, side 2 is 4, and side 3 is 5. And the area of the triangle is 6, as it is a right angle triangle. You can just do half into base into height, which is half into 3 into 4, which is 6. And note that though T is an object instance of the triangle class, and the triangle class itself does not have any method named input sides or display sides. So where is this coming from? Like I've said, all the attributes of the polygon class are being inherited by the triangle class, and we have defined these methods named input sides and display sides in the polygon class. So you do not have to define them again in the triangle class, rather you just have to inherit them. And just a minute, my screen is not clear. Just a minute. Okay. Sorry, I have confirmed that it is clear, and those who are facing, difficulty in seeing the clarity, I think just check your network connection and then try to get back. Okay, so where were we? Okay, so the triangle class is inheriting all the attributes from the polygon class, and Though the triangle class does not contain the methods like input sites and display sites, we were able to use them because if an attribute is not found in the class itself, the search continues to the base class, which is here in this case the polygon class. This repeats recursively if the base class itself is derived from other classes. And moving on to the next topic in inheritance, that is method overriding. Method overriding is an ability of any object-oriented programming language that allows a subclass or child class to provide specific implementation of a method that is already provided by one of its superclasses or parent classes. Note that the parent classes can also be called as superclasses. When a method in a superclass has the same name, same parameters or signature, and same return type as a method in the superclass, then the method in the subclass, that is in the derived class, is said to override the method in the superclass. In the above example, notice that the underscore underscore init method, that is the constructor method, was defined in both classes triangle as well as polygon. When this happens, the method in the derived class overrides that in the base class. Generally, when overriding a base method, we tend to extend the definition rather than simply replace it. So this thing can be done using by calling the method in the base class from the one in the derived class. For example, like calling polygon.__init and from the init function in triangle class. Instead of hard coding the name of the base class like polygon.__init, a better option would be to use the built-in function named super. So the super function. In Python, the super function has two major use cases. It allows us to avoid using the base class name explicitly, as well as it helps us working with multiple inheritance. We'll see what is multiple inheritance in just a minute. Let's see an example using the super function. Here we have defined a class named mammal that is inheriting from the object class. Don't worry, we'll define what is an object class soon. So this contains a constructor __init and a parameter named mammal name. So the constructor prints the name of the mammal as a warm-blooded animal, and then a dog. A dog is also a mammal, so it inherits from the mammal class. And then the constructor contains a print statement that is dog has 4 legs, and note the use of super function to call the init function of the base class, that is mammal class. So when you run this, you get dog has 4 legs, and then the init function with the parameter dog of the base class is called, and dog is a warm-blooded animal is being printed over here. So that is the use of super function. Here we call the __init method of the mammal class from the dog class using the super.__init __dog instead of mammal.__init and passing self and dog as a parameter. Since we do not need to specify the name of the base class when we call its members, we can easily change the base class name if we need to. So that allows us to, change the name of the base class in one place and do not worry about the breaking of code in some other place. Just a moment. Okay, sorry for that. Next, we're going to discuss about the is instance and is subclass functions. First, the is instance function. The function is instance returns true if the object is an instance of the class or other classes derived from it. Note, each and every class in Python inherits from the base class named object. Like just now we have used a mammal class that is inheriting from the object class. You don't have to mention this explicitly, it is done implicitly. Each and every object, that is each and every class, inherits from the base class that is named object in Python. That is mandatory and it is implicit. So here we have defined, above we have defined a triangle instance of the triangle class named T. So here we are checking if T is an instance of the triangle class, and it is, since true is returned to us. And if since the triangle class is inheriting from the polygon class, every instance of the triangle class will also be an instance of the polygon class. We can see this by running the dot instance method, and you get true. That is, T is also an instance of the polygon class. And T is an instance of the float class. I think no. Yes, it is no, because we are not inheriting from the float class. But as we have said just now that every class in Python is inheriting from the object class implicitly. So T will also be an instance of the object class. You can confirm that by running the isInstance method T comma object, which is returning true. Okay. So now let's move on to the second function, that is isUbclass function. The function isUbclass is used to check for class inheritance. It returns true if the parameter is a class that inherits from the second parameter class. Note, just consider the above example where we have used a mammal and a dog class. The dog class is inheriting from the mammal class. So, is mammal class inheriting from the dog class? False. The dog class is inheriting from the mammal class. So you get over true here. The dog class is inheriting from the mammal class. Don't get confused over here. Moving on to the next topic, that is multi-level inheritance. A derived class can act as a base to another derived class. This is called multi-level inheritance. It can be of any depth in Python. A base class is, and then a derived class, and then a derived class, and then a derived class, and then so on. In multi-level inheritance, features of the base class and the derived class are inherited into the new derived class. This is an image that depicts the same thing. This is a base class, the features of base class, and the derived class. It includes features of both the base class and the derived class 1, that is, and the second derived class that is derived from the derived 1 class, and it contains features of both the base class, the derived class 1, as well as the derived class 2. So let's see an example on this. Here we have defined a class named base, that is the base class, and a derived class that is derived from the base class, and its name is derived 1, and a derived class and a class derived 2 that is derived from the derived 1 class. The same hierarchy as shown in this image. So the base class has an attribute a equal to 10, and the derived 1 class has an attribute b equal to 20, and the derived 2 class has an attribute c equal to 30. So note that all the three attributes are class attributes, and we create an object named obj of the derived 2 class, and when you print obj.c, you get 30 as an output. That is an attribute of the derived 2 class. As well as, since it is inheriting from the derived 1 class as well as the base class, you get the attributes of both the classes inherited to the derived 2 class. That is, if you try to find out the value of obj.a, obj.b, and obj.c, you get 10, 20, and 30. The same thing applies, though the derived 2 class does not have any attribute named a equal to 10 and b equal to 20. It is inheriting from the base class and the derived 1 class. So this is an example of multi-level inheritance. An object of derived 2 has all the attributes of both base class and derived 1 class. The same concept applies for methods as well. Note that an instance of derived 1 inherits attributes from the base class, but not the derived 2 class. So if we are creating an object named derived 1 obj, that is an instance of the derived 1 class, and that instance has an attribute named a and b, whose values are 10 and 20 respectively. But it does not have an attribute named c, since it is not inheriting the derived 2 class. Note this point. Okay, moving on to the next type of inheritance, that is multiple inheritance. A class can be derived from more than one base class in Python. This is called multiple inheritance. In multiple inheritance, The features of all the base classes are inherited into the derived class. The syntax. The syntax for multiple inheritance is similar to single inheritance. Let's see the syntax. Here there is a class named base1 and the body of the class, a class named base2 and the body of the class, and a class named multi-derived, which is deriving from both the base class 1 and base 2. So we are mentioning base 1 comma base 2 in the parenthesis. That is, the multi-derived class is inheriting from the base 1 class as well as the base 2 class and the body of the multi-derived class. This is the syntax, and this is a small image that depicts the multiple inheritance. Note the class base 1 and base 2, the features of base 1, and the base 2 contains the features of base 2, and multi-derived class contains the features of both base 1, base 2, as well as its own features. The multi-derived class inherits from both base 1 and base 2 classes. Let's see an example. Here we have defined a class named base 1, a class named base 2, and a class named multi-derived that is deriving both from the base 1 class as well as the base 2 class. So the base 1 class has an attribute A equal to 10 and a class method that is used to print the value of the class attribute A. Similarly, the same thing with base 2 class, and obviously the same thing with the multi-derived class. And we are creating a object called multiple of the multi-derived class. And though the multi-derived class does not have an attribute class method named display A, we are able to use that method from the base 1 class from which multi-derived class is inheriting upon. So we use that to print the value of A, which is 10. And similarly, the display B function prints the value of B, which is 20. And the display C function that is local to the multi-derived class is used to print the value of C, which is 30. Okay. And now another important topic, method resolution order, or MRO. We have discussed earlier that every class in Python is derived from the object class. It is the most base type in Python. So technically, all other classes, either built-in or user-defined, are derived classes, and all objects are instances of the object class. Let's use the isInstance method to verify this. So here 1, 2, 3 is an integer, and we are checking if 1, 2, 3 is an instance of the object class. Yes, it is, because it is the isInstance method is written in true. And here we are using a float to check if a float object is an instance of the object class. And yes, it is. Similarly with string and user-defined class that is multi-derived, we have defined above. It is true. And the base one also we have defined above is true. So this proves our point that every object in Python is derived from the object class. Okay. In the multiple inheritance scenario, any specified attribute is searched first in the current class. If it is not found in the current class, the search continues into the first parent class. If not found, then the second parent class, and so on. And then the search continues so on. Once all the direct parents are searched and the attribute is not found, then the search occurs in the parents of the first parent class, and so on. That is, the grandparents of the class we are currently interested in. This recursive process repeats until the hierarchy of inheritance is exhausted. So in the above example of multi-derived class, the search order will be, let's see this. The search order will be multi-derived. Suppose we are using an attribute. Python searches for the local within the body of the multi-derived class. If it is not found, it is searched in the first parent class, that is the base 1 class. If it is not found in the base 1 class, it is searched in the next parent class, that is base 2. If it is not found in this class too, it goes on to the object class. As you can see over here, the search order is multi-derived, and then base 1, base 2, and then finally the object class. This order is also called linearization of multi-derived class, and the set of rules used to find this order is called method resolution order, or MRO. The MRO of a class can be viewed as the __MRO __attribute or the MRO method. There is not much difference between the two. The former returns a tuple, that is the underscore underscore MRO underscore underscore attribute returns a tuple, and the MRO method returns a list. We use the underscore underscore MRO to find the method resolution order for the multi-derived class. As you can see, the first is multi-derived, and then base 1, and then base 2, and then object. So using the same functionality with the MRO object function method, you get the same thing but in a list. Note this is a list due to the use of square brackets, and this is a tuple due to the use of parentheses. That's the only difference between those both. Now let's see a complicated example. Here, this is an object class, and then three classes named X, Y, and Z, and a class A that is inheriting from X and Y, a class B that is inheriting from Y and Z, and a class M that is inheriting from A, B, and Z. So this is the code. So note the MRO for this for the class M. First it is M, that is the same class it is located in, and then the first parent A, and then okay, so it is the first M is searched, and then it moves on to A, and then the parent of A, which is X, and X, then B, that is the second parent B, and then Y, and then Z. So this is the method MRO of the M class. That is the same example as that is depicted using this image. So the next type of inheritance is diamond inheritance. So this picture best describes what diamond inheritance is. So there is a class A, and there are two classes B and C that are inheriting from the class A class, and there is class D that is inheriting from both B and C classes. So the name is given due to the diamond shape that is formed during this inheritance. So below is an example that shows a diamond inheritance, a class A, and the same example as this, as depicted in this image, a class A that is deriving, that is the base class, and a class B that is deriving from A, and a class C that is deriving from A, and a class D that is deriving from both B and C. And here we are creating an instance of the D class named R, and we are invoking a r.rk method. Note that the class D does not have any rk method, so let us see what output will be printed. Oh, in class B. So the method that is r.rk is invoking this method that is in class B. So why is that happening? You have to look at the MRO, that is the method resolution order. So you see over here. So the method resolution order is D, B, C, A, and an object. So the RK method is not present in class D, so the search proceeds to class B, which is the next in the MRO, and then there is this RK method found, so that is being invoked. Okay, so the next topic is the use of the super function with multiple inheritance. Okay, so this is a bit lengthy example. Here we have defined a base class named animal and a class named mammal that is inheriting from the animal class, a non-winged mammal that is inheriting from the mammal class, a non-marine mammal that is inheriting from the mammal class, and a dog class that is inheriting from both the non-marine mammal and a non-winged mammal over here. So here we are creating an instance of the dog class named dog. So when you run the constructor of the first, that is the dog class, here let's run this cell to see what actually happens, and then we'll have a brief discussion about it. Okay, so what is happening? The constructor of the dog class is being called, and then the dog has 4 legs is being printed, and then the super function is used to call the constructor of the base class, parent class. So the first parent class is non-marine mammal, and then it is called, and then as you can see, dog can't swim. That is being printed next. Dog can't swim, and then that again called super underscore underscore init non-marine mammal. And the parent of the mammal class, non-marine mammal class, is mammal. But there is a small change over here. There is a second parent class to the dog class, that is non-winged mammal. So there is the constructor of the non-winged mammal class is also called using this single line, the single statement, as you can confirm by the dog can't fly output that is printed following the dog can't swim. So which is coming from the non-winged mammal class, which is the second parent of the dog class over here. Note this. This particular output is coming from this constructor. Okay, and next, there are no more parent classes for the dog class. So then the next output that is being printed is dog is a warm-blooded animal. Since we have stopped here in the non-marine class, and then this in itself calls the constructor of the mammal class, so you get dog is a warm-blooded animal from this class. And then this itself calls the base class, which is animal, and then to print the output dog is an animal. This might be a little confusing, so let's look at the dog method resolution order for the dog class. Yeah, as you can see over here, the first is the dog class, and then the non-marine mammal, which is the first parent, non-winged mammal, the second parent, and then mammal, which is the first parent of the parent of the dog class, and then animal, and then object. So this is the dog method resolution order for the dog class, and here we create another instance for the non-marine mammal named bat. So the same thing happens, non-marine mammal bat can't swim, and then the parent of the non-marine mammal class is mammal class, and this is called, to print the output, bat is a warm-blooded animal, and then the parent of the mammal class, that is animal class, is called with the constructor, and then bat is an animal is being printed. So we can confirm this by using the method resolution order for the non-marine mammal class over here. The non-marine mammal class, the animal class, and the object class. So this is the use of the super function in multiple inheritance, as well as an example that demonstrates the use of method resolution order, or MRO. Next, encapsulation. This is another most important topic in object-oriented programming, not just in Python, but any other object-oriented programming language. So what is encapsulation? Encapsulation is one of the fundamental concepts in object-oriented programming. It describes the idea of wrapping data and methods that work on data within one unit. This puts restrictions on accessing variables and methods directly and can prevent the accidental modification of data. To prevent accidental change, an object's variable can only be changed by an object's method. Those types of variables are known as private. This allows for protection of data. And the term encapsulation is termed using the basic idea of a capsule, the medicine capsule, right? Where all the medicine is packed into one and then closed. It is encapsulated. So the methods of a class and the variables are put in a capsule and they're closed together. So hence the term encapsulation. Next we discuss about protected members. Protected members in C and Java, in C++ and Java, are those methods of the class that cannot be accessed outside the class but can be accessed from within the class and its subclasses. To accomplish this in Python, just follow the convention by prefixing the name of the member by a single underscore. We'll see an example. The protected variable can be accessed out of the class as well as in the derived class, but it can be modified too in the derived class. But it is a convention, not a rule, to not access a protected member outside the body of the class. So though you can access and modify a protected variable, it is upon the programmer to not modify or access a protected variable. and the protected variable start with a single underscore. It is a convention, not a rule. So here is an example: a base class and a constructor and an attribute, instance attribute named underscore a, whose value is assigned 2, and a derived class that is inheriting from the base class, and we are trying to modify the underscore a value inside the derived class. Just a moment. Okay, so here we are creating an instance named object1 of the derived class and an instance named obj2 of the base class. So here we are trying to access protected member of object1 using the underscore a attribute, and the protected member of obj2 using the underscore a attribute. So let's run this cell. So here when we create an instance of the derived class, it is in turn calling the instance of the base class, constructor of the base class, and you see calling protected member of base class and accessing the protected member of the base class to print 2 over here. And here we are trying to modify the value of the protected variable to 3, and after modifying we are trying to print the value of uh, the modified variable. So here you can see 3 that is being printed. And within, not just in the derived class, you can access them outside also. Here, as you can see through this statement, accessing protected member of obj1 to get the value of obj underscore a, that is 3, and the same thing for obj2 dot underscore a, which is 2. Here the value of underscore a for obj2 is 2, since it is not it is not an instance of the derived class, where when we create an instance of the derived class, we are changing it to 3. Since it is not an instance, the value remains 2 itself. So that is how this code works. And you can see another example below. We are trying to modify the protected variable of the object2 class, that is an instance of the base class, using the underscore a attribute and then assigning a variable 100 to it. So will an error be generated? No, there is no error. So will the value be changed? Yes, it is changed. So you can always access it, like we have discussed previously. You always have the freedom to access it, but it is a convention to not access or modify the protected variables of a class. And you can see over here, obj1 dot underscore a remains 3 because it is a separate object. We are not changing the value of the underscore a attribute of the first object. Rather, we are just changing it in the second object. And then another type of methods, members, that is private members. Private members are similar to protected members. The difference is that the class members declared private should neither be accessed outside the class nor by any derived class. Note the small change between the private and protected members. In Python, there is no existence of private instance variables that cannot be accessed except inside a class. However, to define a private member, prefix the member name with a double underscore. Let's see an example. Here we have a base class and the constructor that is initializing the value of a normal attribute, to the value of a, the literal a, and an underscore underscore c attribute that is a private member, to the value underscore underscore c. And then a derived class that is deriving from the base class, and then the constructor, you are calling the constructor of the base class using the super function. And then here we are trying to call the private member of the base class inside the constructor of the derived class. And we are creating an instance named obj1 for the base class. And here we are trying to print the value of a. Since a is a non-private member, it will be printed normally like this. The value of a of the attribute a is being printed. But when we try to create an object obj2 of the derived class, it will raise an attribute error. See, because we are trying to call private member of the base class. Even the derived classes do not have access directly to the private members of the base class. And also note that when we try to access the private member of the obj1 class outside the derived class, even then we will get an attribute error like this. Base object has no attribute underscore underscore c. So this is how we can prevent derived classes and global access to few certain attributes. But there is a workaround for this. But what is what happens if we have to access it for some reason, not directly but indirectly, and we have to change it? So here then we can use the setter and getter methods, as you can see in the below example. It's the same example, it's just that I've added two another methods, the getC at method and then the setC method. So here when we try to create the same thing, the value of attribute A, that is A, is being printed. And when we try to access the underscore underscore C attribute, we get an attribute error just like previous. But when we create an object 2 of the derived class, note the small change over here. Here we are using the self.getC method to return the value of C over here. Here we are not accessing the value of the underscore underscore C attribute directly. Rather, we are using a getter method to retrieve the value of the underscore underscore C attribute. And then a set underscore C method to change the value of the underscore underscore C attribute. So this code does not raise any error unlike previously. See, you can easily access private attribute underscore underscore C underscore is equal to underscore underscore C. And you can also access it outside of the derived class using the .getC method. The same thing, underscore underscore C is being printed, so you can access it. And also you can change the value of the underscore underscore C attribute using the setC function or setC method. So we are changing the value of underscore underscore C from underscore underscore C to private. Now let's see what do we get over here. Okay, so we have changed the value of C underscore underscore C to private. So that is the use of setter methods and getter methods. It helps us to access the private members not directly but indirectly. We can restrict if there is something that is very private and needs to be hidden from the outside world at any cost. We just do not write the setter and getter methods for that particular attribute. So that's it. Moving on to another important topic of in object-oriented programming, that is polymorphism. First of all, what is polymorphism? The literal meaning of polymorphism is the condition of occurrence in different forms. Polymorphism is a very important concept in programming. It refers to the use of a single type entity, method, operator, or object to represent different types in different scenarios. I'll tell polymorphism in a very simple example that everyone can understand. Just a moment. Okay, sorry for that. And I think now wherever you see, if you explore social media, everywhere there is Balaya Akhanda Akhanda. So if you guys have watched Akhanda movie, there is two different characters of our Balaya, right? One is named Murli Krishna and the other one is named Akhanda. So he's the same person, he's our Balaya, and he's existing in two different forms. One is Murli Krishna and the other one being Akhanda. So that is polymorphism, existence of the same thing in different forms. I think that gives you a better understanding of what polymorphism is. So now let's move on. Polymorphism in operators. The same operator, when applied on different instances of different classes, the operator behaves differently. That is, it has different functionality. So one such example is polymorphism in addition operator. We know that the addition operator is used extensively in Python programs, but its usage is not unique. So we'll see for integer data types, the plus operator is used to perform arithmetic addition operation. As you can see in this example, there are two variables num1 and num2 whose values are 10 and 20 respectively. And then when we perform num1 plus num2, we get the arithmetic addition value, that is 30, being printed. But the same plus operator can be used for string types to perform concatenation. Note this example. First name is Nikhil, the last name is Nandam, and then when you perform plus operator between the strings, it performs concatenation rather than arithmetic operation. It is the same operator, the plus operator, but it is being used to perform different functionality. And then for another example, for lists, the plus operator is used to extend one list onto the other. So here is a list 1 that contains elements 1, 2, 3, and a list 2 that contains elements 4, 5. So when you do list 1 plus list 2, it extends list 2 onto list 1 to produce a new list that contains 1, 2, 3, 4, 5 as its elements. It is the same plus operator, but it is performing different functionality for different instances of different classes. Okay, so this is one such example of polymorphism in addition operator. There are many such examples. Many operators can be polymorphic. Many other operators like minus, multiply, etc. So the plus operation is one such example. We move on to the next topic, function polymorphism. There are some functions in Python which are compatible to run with multiple data types. We see one such example is the Len function. There are many such examples. We'll discuss one of them, and that is the Len function. It can run with many data types in Python. Let us look at some use cases of the len function. Here we are using len function to print the length of the string Nikhil Nandam with a space, that is 13. You get 13 being printed. Here the next example, we are using len function to find out the length of a list, which is 5 for this list that contains of 5 elements 1, 2, 3, 4, 5. The len function can also be used for a dictionary to print out the number of key value pairs that are present in the dictionary. Here there is one key, one value, one key, one value, one key, one value. So there are 3 pairs of key value pairs. So when you run the len function on that dictionary, you get 3 printed as an output. So the length of the dictionary is 3. And lastly, the length function can also be used for a set to find out the number of elements that are present in a set. Here, as you can count, there are 6 elements in the set, and then the len function returns 6. Note that it is the same len function that we are using for different use cases, but we are able to use the same len function to different objects, and those objects belong to different classes also. So this is an example of function polymorphism. Let's look at another type of polymorphism, that is class polymorphism. We can use the concept of polymorphism while creating class methods, as Python allows different classes to have methods with the same name. We can then later generalize calling these methods by disregarding the object we are working with. Let's look at an example. Here we have created a cat class with an instance method named info and a makeSound method. Also, here we have created a dog class with the same method named info and the same method named makeSound as that of the cat class. And here we have created a cat1 instance of the cat class by passing the parameters kitty and 2.5 as the attributes to the constructor, and an instance of the dog class named dog1 by passing fluffy and 4 as the attributes. And note this carefully. We are wrapping these both objects in a tuple, and then we are iterating over those objects using the animal. Note that we are using animal for both cat1 and dog1. So when we run animal.makeSound, if it is an instance of the cat class, the makeSound of the cat class, that is this, will be invoked. And if it is a cat class again, the info method, that is this of the cat class, will be invoked rather than this of the dog class. And the makeSound again, this is being invoked. This will be invoked. Let's see the output to get a better understanding. See first, the value of the animal will be cat1. So when animal.makeSound is used, since cat1 is an instance of the cat class, the makeSound method of the cat class will be invoked, not the makeSound method of the dog class. The same thing with info and the makeSound again class. So you can see over here, meow, I'm a cat. That is coming from these both methods, meow, since cat is an instance of the cat class. And when you run the same animal.make sound on the instance of the dog class, you get a different output, that is bark, I'm a dog, that is corresponding to these methods that are present in the dog class. We were able to call different methods of different classes. I mean, they have the same method name, but they belong to different classes. But we were able to call them using the same variable named animal. So that is how class polymorphism works. The same explanation lies over here. Here we have created two classes, cat and dog. They share a similar structure and have the same method names, info and make sound. However, we were able to call the corresponding methods of those instances using a common animal variable. This is possible due to polymorphism. And then the last topic in polymorphism and in inheritance. We can redefine certain methods and attributes specifically to fit the child class, which is known as method overriding. Polymorphism allows us to access these overridden methods and attributes that have the same name as the parent class. So here is an example where I've created a class named shape and that contains a method named area, fact, and this is a special method that we will discuss in a few moments from now, __ str __ method. For now, just leave it like that. And here is another class named square that is inheriting from the class named shape. And here is a method named area, or a method of the shape square class area. Since the square class is already inheriting from the shape class that contains the same method name area, this definition of the area method will override this particular definition for each instance of the square class. And then the same happens with the fact class. There is a fact class in the shape class as well, but this particular method will override the definition of the fact method from the shape class for all the instances of the square class. Okay, and there is another class named circle that is inheriting from the shape as well, and it contains a single method named area that will override the method named area in the shape class from which it is inheriting. So here we are creating an instance named A of the square class and an instance named B of the circle class. So we are passing in 4, that is the side of the square is 4, and 7 is the radius of the circle. So let's run this, and we have created, okay. So we print what is B. B is a circle. B dot fact. What is the fact that is associated with a circle? I am a two-dimensional shape. This is because there is no fact method that is associated only with the circle class. Rather, it is simply present in the shape class from which the circle class is inheriting. So this class is invoked that, and running circle.fact prints I am a two-dimensional shape, as you can see over here. And b.area, the area of the circle is calculated by pi into, wait a minute, pi into 22 by 7, just a minute, 22, 7, okay. So the area is being called as pi r square. This is the value of pi, 22 by 7, and then the r, and then the square. So you can see the area of this circle being printed as 154, rather than doing nothing, that is pass. So the pass area method is overridden in the circle class using this following definition. And then the same thing applies for the square class. When you run A is a square, and A dot fact. Here note the difference between the circle class and the square class. Here the square class has an overridden method named fact that overrides the definition of the fact method that is present in the shape class. So we are returning squares have each angle equal to 90 degrees, and so that fact about the square is being printed over here. Squares have each angle of equal to 90 degrees. And then the area of the square whose side is 4 units is 16. So which is different from the area formula that we are used to calculating the area of the circle. Okay. Here we can see that the methods such as underscore underscore str underscore underscore, which have not been overridden in the child class, are used from the parent class. Due to polymorphism, the Python interpreter automatically recognizes that the fact method for object A, that is an instance of the square class, is overridden. So it uses the one defined in the child class. On the other hand, since the fact method for object B, that is an instance of the square of the circle class, is not overridden, it is used from the parent shape class. A small note. Method overloading is another concept that is present in programming languages like Java. It is a way to create multiple methods with the same name but different arguments is not possible in Python. So method overloading is not possible in Python. And moving on to the last topic, operator overloading. So what is operator overloading? Python operators work for built-in classes, but the same operator behaves differently with different types, as we have seen in polymorphism in operators. For example, the plus operator will perform arithmetic addition on two numbers, merge two lists, or concatenate two strings. This feature in Python that allows the same operator to have different meaning according to the context is called operator overloading. What happens when we use these operators for objects of a user-defined class? Let's see an example where we have defined a class complex number which is used to represent complex numbers. So here is a class named complex numbers. Complex number, it has an attribute real as well as an imaginary, just like the attributes that are present for a complex number. And here we create two complex numbers, or rather two instances of the complex number class by passing in the values 3, 4 and 6, 8. So the first C1 is a complex number 3 plus 4j, and the C2 is a complex number 6 plus 8j. So when you run print C1 plus C2, you'd expect 3 plus 4, 9 plus, and 4 plus 12. 4 plus 8, which is 12. So you'd expect 9 plus 12j to be printed, but that is not the case. Unsupported operand type for types complex number and complex number. Okay, here we see that a type error was raised since Python didn't know how to add two complex number objects together. This task can be accomplished by the concept of operator overloading. Before we discuss about operator overloading, we need to discuss about Python special functions. So what are Python special functions? Class functions that begin with a double underscore are called special functions in Python. These functions are not the typical functions that we define for a class. Think of a special function that we discussed already. If you guessed underscore underscore in it, then you are right. It is a special function, constructor. It is since it begins with the double underscore, it is a special functions. Using special functions, we can make our class compatible with built-in functions. So when we try to print the value of C1, which is an instance of the complex number, you get something like this. Complex number object, blah, 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 something stuff like this. So which is not pretty useful for us to interpret what the object is. Suppose we want the print function to print the value of the complex number instead of what we got. We can define an underscore underscore str method in our class that controls how the object gets printed. So it is the same complex number class with the underscore underscore str underscore underscore method defined to print the value of the complex number as we want. That is the real part plus the imaginary part nj. So here we are defining the same two instances C1 and C2 for the complex number class. And then now when we run print C1, you get 3 plus 4j printed neatly. Other than compared to this thing which is non-interpretable actually. So that is the use of a special function called underscore underscore str that is used to, print the proper attributes or the values of the state of the instance in a way we want for us to interpret. So we can also use underscore str of C1 to get the same thing. So when you use str of C1, Python internally calls C1 dot underscore underscore str method. So that is why it is given the name special function. Now let's get back to operator overloading. So overloading arithmetic operators. Firstly, we talked about the plus operator. To overload the plus operator, we need to implement the underscore underscore add underscore underscore function in the class. It would be ideal to return an object of the same class. The same thing with minus operator. We need to implement the underscore underscore sub underscore underscore function in the class. And also for the multiplication operator, that is the star operator, you have to implement the mul underscore underscore mul underscore underscore function in the class. That would, and the bodies of these functions should contain, should be able to modify the state of the instance in such a way that it is uh, proper for the, it performs a proper operation for the instances of those classes. Let's see an example. Let's use these functions to extend the functionality of our user-defined complex number class. So here it is the same complex number again, the same constructor, but here we have defined three new methods, special methods rather, underscore underscore add, underscore underscore sub, underscore underscore mul methods. So here we can see when we add two complex numbers, the real parts gets added and the imaginary parts gets added, and we are returning a new instance of the complex number class with the proper attributes, real and imaginary. The same thing with this underscore underscore subclass, and the same thing with multiple underscore mul class. And a slight change in the underscore underscore definition str class. You'll note why this small change in just a moment. For now, again, we create two instances of the complex number class C1 and C2 uh, with real value 3 and 4, imaginary real value 3 and the imaginary value 4 for the C1 instance, and then 6 and 8 minus 8 for the C2 instance. So when you run print C1 and C2, you get 3 plus 4j and then 6 minus 8j. So this, and when you try to add these two instances, that is C1 and C2, and when you try to print them, you get 9 minus 4j rather than the type error which is generated above. So you can compare this. 3 plus 6 is 9, so you get 9, and 4 plus minus 8 is minus 4. So the addition function works properly. You can, I mean, we are simply able to add two complex number objects, that is instances of the uh, user-defined class named complex number using the simple plus operator by overriding or by using a special method named underscore underscore add method. So the same thing is used for C1 and C2. I mean C1 minus C2 and C1 star C2. What actually happens is that when you use C1 plus C2, Python calls C1 dot underscore underscore add C2, which is in turn complex number dot underscore underscore add underscore underscore C1 C2. For this, the addition operator is carried out uh, the way we specified, like adding both the attributes of the real, adding the real attributes of both complex numbers, and then the imaginary part of the both complex numbers. Similarly, for C1 minus C2 and C1 star C2, Python calls C1 dot underscore underscore sub underscore C2 and C1 dot underscore mul underscore C2 respectively. So you can see the output. C1 minus C2 is 3 minus 6 is minus 3, and 4 minus of minus 8 is 4 plus 8, which is 12j. This is the output that is being printed. And when you perform C1 minus C2, you get minus 3 plus 12j. And when you perform C1 star C2, you get 50 plus 0j. If you are familiar with complex number theory, I think this, you can verify this on your own, C1 star C2. And similarly, we can overload other operators as well. The special functions that we need to implement are tabulated below. So you can overload the addition, subtraction, multiplication, power, division, floor division, operators, etc., bitwise left shift, and all these operators using these methods underscore underscore add underscore underscore mul, and all of these are tabulated in a neat table. Refer to this when the material is shared to you. Although these all the other operators are rarely used, we generally use the addition operator, subtraction operator, and the multiplication, and mostly division. That's it. So, moving on to the next topic, that is overloading comparison operators. Python does not limit operator overloading to arithmetic operators only. We can overload comparison operators as well. Suppose we wanted to implement the less than symbol, greater than symbol, and equal to symbols in our complex number class. So what do we do? The less than operator. To overload the less than operator, we need to implement the underscore underscore lt underscore underscore function in the class. This function must return a Boolean value that is a true or a false, depending on some certain conditions that is particular to the class, particular to every instance of the class. And then the greater operator, the same thing, we use the underscore underscore gt underscore underscore method function in the class, and also the is equal to method to implement the underscore underscore equal eq underscore underscore method to overload the equal to operator. It must return a Boolean value, true or a false. Let's see an example of how these functions extend the functionality of our complex number class. So this is a complex number class. All these are separate methods. Till now we have discussed above underscore underscore and underscore underscore mul. And then this is the underscore underscore lt method that we have just discussed above, the underscore underscore gt method, and the underscore underscore eq method. So we are comparing two complex numbers based on their magnitudes. If the first if the magnitude of the first complex number is less than the second complex number, it returns true, else it returns false. So this is the code, and here we are creating three instances of the complex number class, C1, C2, and C3, and their values are 3 plus 4j, 6 plus 8j, and 8 minus 6j. So when we run C1 greater than C2 to check if it is true or not, it returns false, because the magnitude of the C1 is 5 and the magnitude of C2 is 10. Since the magnitude of C1 is less than the magnitude of C2, here it is returning false. I mean, we have defined the method in such a way. And when you run C1 less than C2, it returns true. And when you run C2 equal to C3, it returns true, because the value of magnitude of C2 is 10 and the magnitude of C3 is also 10. So it returns true. Similarly, the special functions that we need to implement to overload other comparison operators are tabulated below. The less than is implemented using the underscore underscore lt underscore underscore. The less than or equal to is implemented using the le. Equal to is implemented using the eq, and similarly not equal to using ne, greater than using gt, and greater than or equal to using ge. So that's it for operator overloading. And finally, we discuss the key points of OOP, that is object-oriented programming. Object-oriented programming makes the program easy to understand as well as efficient. Since the class is shareable, the code can be reused, and it allows for it basically eliminates the need for code duplication and keeps the code short, simple, and concise. Data is safe and secure with data abstraction, as we have discussed in encapsulation concepts, and polymorphism allows the same interface for different objects, so programmers can write efficient code. So that's it, guys. That's a wrap for the Python training sessions organized by Coding Club, and this is our last session, as I have mentioned. Uh, First of all, I would like to thank everyone who's actively participated in these sessions, and made use out of the material that we provided. And it really takes a lot of efforts to prepare the material as well as to create the quizzes and host YouTube live streams and teach you guys. So thank you for staying on with us. As I've mentioned in my first session, that this is the first time that I'm teaching someone rather than being taught by someone. So I will remember this throughout my lifetime as an important achievement. So thank you guys for being part of this. Uh, that's it. Thank you. Thank you guys for staying along. I'm ending the stream.